So today we're going to be talking about logarithms and exponents. So hopefully we remember a little bit from Algebra 2 that we covered logarithms and exponents, but we're going to review some of those properties, characteristics, just so that we're all on the same page. So both exponentials and logarithms are functions. So remember that means that they will pass our vertical line test, and it also means that that we can look at their graphs, which is what we'll be doing in our next lesson. But let's recall that an exponential function is a function with a variable in the exponent. So it doesn't just have an exponent, because if I had f of x equals x squared, that's not an exponential function. In order for it to be an exponential, remember it has to be of the form y equals b to the x. My x value is going to be what is in my exponent. So remember that our logarithmic function is going to be the inverse of an exponential function. Also, remember that for our logarithmic function, we have two special types of functions. They are going to be our natural log and remember that is going to be a base of e, and we will write that as ln of x. And then we also have a common log, which is going to be a base of 10. And we go ahead and just drop the 10 and say that it's understood whenever I don't have a base, that I have a base of 10. Alright, so remember that we have two types of forms. We have exponential form and we have logarithmic form. And depending on the problem that we're doing, it's going to be necessary to have it in one form or the other. So our exponential form is going to look like b to the y equals x, and our logarithmic form is going to be log base b of x equals y. So notice So my base stays the same. It's going to be the base of my exponent, okay? My y is going to become my new exponent, and then my x is going to be moved to the other side. So let's do some practice on converting back and forth between logarithmic and exponential form. So this says write each equation in exponential form. So they give it to us in logarithmic form, and they want us to rewrite it in exponential form. So remember, like I said, your base of your logarithm is going to be your base of your exponent. So I have it 2. And then a key thing that I'm going to repeat a lot is that logarithms equal exponents. And what I mean by that is that whatever our logarithm equals, which in this case is 3, is going to become our exponent for our exponential form. So since my logarithm equals an exponent, I know that my exponent for my exponential form has to be 3. And then I know that my only other choice is that it's going to equal whatever's on the inside, which is 8. Okay, so again, on part B, my base stays the same. And again, we know that logarithms equal exponents. So since my logarithm equals -4, I know that -4 becomes my exponent. And then that's going to equal whatever's on the inside of my logarithm, which is 1 over 256. Which makes sense because remember that whenever we have a negative exponent, it's going to turn it into a fraction. So let's go ahead and go the other direction. This time they give it to us in exponential form, and we want to rewrite it in logarithmic form because sometimes we'll need to put it in one or the other, so we need to be able to go both directions. So again, my base of my exponent is going to be the base of my logarithm. So I'm going to have log base 15. Okay, it's important to remember that the little subscript, the 15, is my base. It is the power, basically, that we're kind of exponentiating things to by a power of 15. So then we know that logarithms equal exponents. So I know that my exponent is going to go over to the other side. And then on the inside of my logarithm, is going to be the 3,375. Then on my other one, again, my base this time is going to be 4. Logarithms equal exponents, so I know that my logarithm is going to equal 1/2. And then on the inside, I'm going to have 2. So sometimes we're going to need to evaluate logarithms. Now, once we get better at this, we can maybe do this in our head. So we know that logarithms equal exponents. So I'm saying I'm looking for an exponent of 16 that will give me 4. But if we can't do that in our head, what we can go ahead and do is that we're going to set whatever it is we're trying to evaluate equal to some variable, because we don't know what it is yet. And we're not super comfortable with logarithms most of the time. However, most of us are pretty good with our exponents. So what we're going to do is rewrite this in exponential form. So we would have 16 to the a power equals 4. Now, hopefully we remember that when I'm looking at exponentials, if I can rewrite both my sides of my equations with the same base, we're allowed to set our exponents equal to one another. And if we notice, we can rewrite 16 as 4 squared. And remember that whenever we raise a power to another power, we're going to multiply. So I would have 4 to the 2a equals 4. And we don't have an exponent on the right side, but remember that it's going to be an understood 1. And so now that our bases are both 4, we can go ahead and say, well, if I know my bases are the same, the only way that the entire value can be the same is if the exponents are also the same, which means that my a value would have to be 1/2. Or, in other words, we know that log base 16 of 4 has to equal 1/2. Alright, so then like I said before, logarithms are the inverse of a exponent, which means that we can find the inverse of either our exponentials, or we can find the inverse of our logarithms. And we're going to have to either convert from exponential to logarithmic form or logarithmic to exponential form, depending on the type of problem that we're doing. So in this case, we're going to look at one of each type. So on our first example, we're starting with a exponential, and so that means that our inverse is going to be a logarithm. So remember, our first step when we are finding inverses is to set equal to y, which in our first example is already set equal to y, so we don't have to worry about that. Then our next step is to switch x and y. So in this case, I would get x equals -1/2 times 5 to the y minus 2. Then we want to solve for y. So in order to be able to write it in logarithmic form, we need to have whatever is being raised to a power to be by itself. So our 5 is what's being raised to the power, so we need to make our 5 by itself. So basically we need to get rid of that front number first. So we're multiplying, so we would divide by a -1/2, but remember that dividing by 1/2 is going to be the same thing as multiplying by 2. So we're going to multiply both sides by 2. So I would have -2x. My -1/2 is going to be reduced to 1 by multiplying it by -2. So then I have 5 to the y minus 2. So now that our base that's being raised to an exponent is by itself, we can rewrite this in logarithmic form. So remember, our base of our logarithm is going to be the same as our base of our exponent. So in this case, that's 5. And then logarithms equal our exponent. So we know that it's going to equal y minus 2, which means that our inside is going to be -2x. And then our last step is just going to be to add to both sides. Now it's very important that since we added the 2 after we took the logarithm, that 2 has to be outside of the parentheses of our logarithm. And that's why I included the parentheses around the negative 2x, but not the plus 2. So then our last step is going to be to set equal to f inverse of x or y inverse, depending on what we started with. So in this case, since we started just with just y, we're going to rewrite it as y inverse equals log base 5 of negative 2x plus 2. And that would be the inverse of our exponential function that we started with. Now, since exponentials and logarithms are inverses, that means that it goes both ways. So logarithms are the inverse of exponentials, but exponentials are also the inverse of logarithms. So we can also do it or find the inverse for our logarithms. So our first step, in this case, we will have to set it equal to y. And again, just like before, when we wanted to rewrite it in logarithmic form, we needed our base to be by itself. In this case, we're going to need our log to be by itself whenever we start solving. So we're going to switch our x and our y. And then before we can rewrite it in exponential form, we need our log to be by itself. So thinking about my order of operations backwards, normally we do our multiplication and division first, and then we do our addition and subtraction. But because we're basically solving, we want to do those backwards, so that means that we need to subtract 3 first. Alright, then we want to take care of our multiplication. So right now we have multiplied by 2, so that means that we would need to divide by 2. And now that our logarithm is by itself, we can rewrite in exponential form. So remember that logarithms equal an exponent. So my base of my logarithm, which is 3, is going to be my base of my exponents. Logarithms equal exponents, so I know that my exponent is going to be the x minus 3 divided by 2. And then that's going to equal y. And again, we need to rewrite that as the inverse, which is what our little negative 1 means, of f of x, is going to be 3 to the x minus 3 divided by 2 power. And that would be our final answer.